let's start with this Azure Sentinels. The Terraform. Okay, so my name is Riwut. Member of MPP. I'm working with Cognizant and doing some enterprise architecture. And today we are going to discuss about this Terraform. If you haven't knows about it, so basically when we build an infrastructure, right, and then we want to install anything, we want to configure the firewall energy, like what Faisal has been presenting this morning, and then configuring all these network connections, all these devices. So instead of doing it manually, we can use the Terraforms, and this Terraform will help us to really generate and manage your infrastructure as a code that you can later on the versioning and then push, configure the state, and so on and so forth. So in this presentations, I will have more on the demo. I'll put more focus on the demo, so you will be able to see what you can do with this Terraform and how this Terraform able to help you manage your environment, right? So before I start, anybody here have been working with Terraform or with Infra? Okay, so what is Terraform? Terraform so you do the what is Terraform, and then we will lead you how to write Terraform resources, what is the best practices, and then how to manage the Azure infrastructure using the Terraform. At the end of the session, I'll show the demo how to create all the development environments, SQL servers with the Terraform, configuring the the firewalls, and so on and so forth. Right. So what is Terraform? So this is tools for the building, right? You can build and change versioning the infrastructure, like I mentioned. So once you do that, you will be able to manage doing the state management, and then after that, you will be able to do the versioning. And the good thing about this one, right? It is enable us to manage any popular service provider like Azure, for example, that we are going to do today. And then we will be able to manage the infrastructure from the Google Cloud, AWS, using almost the same syntax. It's just the different parameters, right? So we'll codify everything from physicals, hardware and VMs, and also containers if you would like to do the containers. That one. The second thing is we will be able to manage the service like email, DNS, energy, etc. And then we will be able to do the build change and versioning. It's very useful. So because when you want to create your own lab, for example, you want to bring your labs or your infrastructure, you will be able to hand over the infrastructure creations to the developers, right? You provide the Terraform resources, Terraform scripts, and then you will hand over this one to the developers, and the developers will be able to build the infrastructure by themselves using the script, and it will be consistent, right? And like I said, it's also support for the multi-cloud provider. So this is what I like about this, because we learn one language. Later you see what kind of language it is, and it's applicable for all the cloud providers. So we don't need to learn very specific about one cloud provider to other cloud providers. So we learn once, and then we'll be able to use it for all. But of course, it's not, we still need to have knowledge about the specific cloud provider itself, because every cloud providers will have their own provider resource inside the Terraform. Okay, so the Terraform will be able to answer a common infra management problem. Right? It will use the TF. So TF is the Terraform files to describe the infra in the DSL language. Right? And then when we apply the Terraform files, the TF files that describe our infrastructure configurations, it will generate the TF state. So TF state is the state of your configuration, state of your infrastructure configurations. So for example, if you create a resource group in Azure, your state will contain the information about the resource group, right? And then, for example, if you add VNet inside the resource group, your state will give the information about the resource group and the VNet that you have built in your infrastructure. So with this one, the Terraform allow us to upgrade, to change, add, or remove resources from the current infrastructure. And at the same time, when you want to build the same thing, you just need to run the TF files, the DSL file, to other environments, and you have exactly the same infrastructure, right? And to do this, we'll need help using the Terraform. We will need Terraform CLI. So Terraform CLI is the command prompt. So you just run the CLI. And then we also need the providers for a specific cloud providers. So for example, for the Azure, we need the Terraform Azure RM. And then for Linux, we have a Linux providers, we have AWS, we have so AWS providers, GCC providers, and so on and so forth. So every provider will have the providers. What we need is to define the TF files, run using the Terraform apply, and then we have the TF state that save the state of our infrastructure based on what we run. Okay. So the next I want to talk is how can we write TF files resources. So TF files is written in HCL. So I think if you've been working with F5, they are also using this almost the same language. So HCL. Basically, when you read this one, so you see this one, the main.tf, this one. So the provider for this line number 2 is showing that the provider is a Linux, right? So, and then it has variable descriptions. And when we read this one, right, I feel that it's a humanly readable. I can read, I can understand it without, taking so much time for me to understand how to write this. Of course, we just need to go back to the syntax. But when we read this, everybody, I hope that everybody who work on the technicals, they can quickly understand what this is, all right, without going in. So for example, we read this one, Linode instance. So it means that it's create a Linode instance with the image of Ubuntu, with the type of G6, and so on and so forth, right? So the key element for the HCL, this first is the blocks. So if you look at this one, right, the blocks. So the blocks is written inside the curly bracket. right? So everything inside the curly brackets are the blocks, right? And then inside the blocks, we have a key and value pair. So key and value pair, for example, we see on the line numbers 3 token. So that's a key, and then the value is a 4 token. And then there's a line number 7. We have descriptions. So descriptions is the key, and then value is this is the location where lineup instance is deployed. So that's the key value pair, right? The next things that we see here is the comments. So the comments will use the hash, right, for the single line comments, and then with asterisk or slash asterisk for the multi-line of comments. So the line number 1 is the comments. And then there's also interpolation syntax. So where the value is start with the dollar signs and then open curly brackets and the variable. So the variables. And then after that, we have the string that is wrapped inside the double quotes and primitive types. We will see later. So primitive types on the list is like the authorized key, line number 17. Right? If you look at line number 17, authorized keys. These are the list of the keys, and it's a wrap in the square brackets, right? And then maps. Later we see how we use maps. So before I go to the how to do it in Azure for Azure, I'll just cover the best practice. So first is of course in every coding we want to avoid hard coding of the resources. So let me show you how to avoid the hard coding. We'll do that, and then we will keep the variable inside the TFRs, right? So for example, you have a dev environment, you have the TFRs for the dev environment, you have a QA environment, pre-prod environment, you have different bar files for different environments, so that you can manage and you can have, nodes that for the dev, you will have this kind of setting. For the UAT, you have a different set of settings. And then number 3, the most important is to always keep the TF states in a version control system. Why? Because like I mentioned before, that after we apply the TF to the and to create our resources, and the Terraform will keep the resources information, the deployment, the current state of your infrastructure inside the TF state. So if you lose the TF state, then you lose the Terraform will lose the knowledge of what is the current state of the infrastructure, right? So we need to keep this TF state inside the version control system like Cheat, Azure DevOps, S3 bucket, and so on and so forth. So you look at that, Terraform also provide a backend for to keep the states to the version control system. So the TF state is one of the very important things that we need to keep, right? And then the third one is don't do simultaneously. So for example, if because it will read the state, the current state of the infrastructure, and you run the same Terraform files at the same time simultaneously, then it will create a conflict. So don't do that simultaneously. And then we can also use the Terraform to import. Any question? Yeah. So we can also use the Terraform to import the existing resources. So for example, there's an existing resources. You have a network layer already created by network team. You have NSG layer created by I don't know security teams. So with this one, right, you can import the current state of that layer and then add, for example, a VMs on top of that without us needing to create all of it again from scratch. So we can use the Terraform import to import the existing resources into the current state and use it as a reference as well as the starting point for the new infrastructure. And last but not least is the use a shared modules. So I give an example. For example, we have we want to create three tier applications. So we have apps, websites, apps, and then DB. And when we want to put this in dev, product, QAT, and then productions. So we don't need to copy paste the TF files, but instead we can use it as a shared module. And in every environment, we will refer that module so that we don't need to repeat the creation again, right? So how do we do the Terraform in Azure? What we need? So first, of course, we need the tools. The tools. Okay. By the way, if you would like to follow, I've prepared also the GitHub. You can clone later, and then you can download these tools. So if you have also your Azure subscription, you can also run it on your Azure subscriptions. So the tools that we need first is the code editors, right? The text editors. So here I'm using Visual Studio Codes, and then we need, of course, the Terraform CLI, and then the Azure CLI. So Azure CLI, you have all of this link. Just download from that links. And then in Azure, of course, we need the Azure subscriptions. And then we also need the Azure service principles, right, for doing this. And then so for the Azure service principle, because of the permissions given to this service principles, please make sure that you keep it secret and you don't include this information into your versioning system, right? So you put inside the git ignore, for example, so you exclude, or you put inside the variable environment variable in the Azure DevOps. So really keep that secret. And the last one is to codify the resource in the TF files and then run the Terraform flows, which is starting from plan. Plan is to see what is your impact of your TF files to the existing resource, and then apply the changes, whether it's delete, update, whatever, to the current infrastructure, and then destroy. I believe you know that is to destroy the infrastructure. We need to delete everything, right? So the last thing is, of course, I keep reminding that please keep the TF state in a version store so that you will not lose the state. Okay, so I'm stopping here before I move to the demo. Okay, so for the demo, you can use, I prepared already the GitHub samples, github.com/sample-terraforms. And you want to follow the demo, you can also use download the Terraform CLI on these locations. If you have a Mac, you download the Mac. If you have Windows, you download the Windows versions. Azure CLI also will require, because the Terraform providers, Azure RM providers, will call the Azure CLI, by the way. And then the last link is about the Terraform RM providers documentations. So all of the Azure RM providers documentation is available in the link. So www.terraform.io providers Azure RM index, right? So let's do the first demo. So we'll do the codify. We'll do the check the Terraform plans, and then do the apply, and then later we destroy. Okay, so let me stop this. While I'm preparing my screens, you may, if you want to have a question, just let me know. Okay, so this is the GitHub sample that I provided. So we have we will have 3 demos today. We'll go through all. We'll see how it helps you. So I'll just clean up this first, and I'll show you what is the state inside my Azure before I start. Right. So I pull up my command prompt, and I will show you what is the state inside my Azure. So what we're going to do, we will do, okay. So here, press, this is my resource group in Azure. Okay, so I'll create a simple resource group. Okay, so I'll create a resource group GAB2020-RT.
Riwut, can you zoom in a little bit? The font is very small.
Font is very small. Okay. Do that.
In Control Plus. Yeah.
Okay.
Yeah. Thanks.
All right. Yeah. So here what we see, right? So what we are going to do is to create a Azure resource group. Of course, we will go to Azure. First thing to do is to create a resource group, right? Before we can do anything. So I will move. I will make this resource group hard coded for the moment, just to show you that you know, we can just later on we will extract this as a variable. So these are the resource group. I put the location in Southeast Asia. The environment is dev. Client is GAB. So you can put any tags here. Tag, and then this command is just to say what are the providers required for this Terraform files. So I will need the Azure RM version 2.5. Yeah, so this Terraform is very actively developed. So we don't want to have a break in our our script. So it's recommended that we stick, we define which versions that this script will run. So here I define 2.5, and then this is MTF, right? So let me run this. So first thing we need to do, can you see this one, command prompt? Big enough or not?
No, again, very small. Wait, can you pick up?
Very small, okay. Channel.
Yeah, this is good. Keep it up.
Okay. All right. So the first thing is to run the Terraform init. So what Terraform init will do, it will download the providers to your local files. So for example, if we have, we ask for the here the Terraform providers Azure RM, it will download the Azure RM providers to your locals, and then make sure that everything is available. So let's run this. So download the providers plugin to your locals, and then make sure that the syntax is also compatible with the version that we are. So I have a network issue, so I just need to run it again, make sure that it's successful. Yeah, look at this one. So it's download the Azure IAM from the HashiCorp repository. It's just like a other repository. We have a .NET repository, but this one is for the Terraform, right? While we are waiting for that, I will show you. Okay, so now if we want to validate that our script is correct, we can run Terraform validate. So Terraform validate will allow us to validate if we have any syntax error, we have incompatibility, it will give us the information. So success, our configuration was valid. So then we can run plan. So plan basically will give us the informations. What are the resources that it will create, it will delete, or will update, right? So plan will give us this information before we run apply. Okay. So it'll try to read the current state because I don't have the current state. So it'll just use a zero state. It will just create a initial state. So zero state, and then it will read what is the difference between the current states and the resource that is being defined inside the TF files, and it give us the information what changes will be applied using this plan. Okay. So after this, we will run the Terraform apply. So we'll apply the plans, apply the Terraform files to the resources, and then we'll see what is the result in the Azure later. So you can put this TF files inside the Azure DevOps into your Azure's pipelines, Azure DevOps pipelines, so that you can create this as part of your DevOps pipeline. So look at this one. Right. So it gives the information plus is creating. And then Terraform will perform a following action. So it will create Azure resource files, Azure resource group with these informations, but the ID will only known of apply. Okay, let's quickly apply this. So this plan will have 1 add, 0 change, 0 destroy. So just run the Terraform apply. Okay, well, it will take some time. So while we wait for that, let's see what next I'll do, right? So like I said that we want to remove this hard coding into a variables. So what we are going to do is to create variables. So we create variables.tf, right? We create a variable.tf and we define the variable names. In this case, I define a variable resource group name, and we can define a default value, or we can remove a default value. And then I also define the variable location here. Okay, and then I will have text, variable text with string map, defaultment and format. So whatever we saw before as a hard coded, we remove as we make it as a variable. Okay. All right. So this is the variables, and then I also additionally I also have the output files, output.tf. So the variables they have output.tf is a hard coded files. So you need to have the same name. Okay, so the output you have the resource locations. I will take the resource group DevOps location. So it gave me the DevOps locations, the resource. Okay. Then I will change the name to use the variable. So I just use the vars dot resource group name. And then for location, I'll just use the var dot location. So var is the variables and then the variable names. Similarly for the text, var dot text. So with this one, right, we will be able to make the the value as a variables. All right, so it's complete. Look at this one, the screen complete. So let's see what happened inside my resource group. Okay. So I don't have the GAB2020 RG, so I just refresh this. So I will have one resource group, and yeah. Okay, so look at this one. So this one is the resource group that we just created. Just simple resource group in the location. Let's see what are the, does it apply the text? Yes. So it's apply the text, the tag like what we defined, client GAB2020 environment dev, and then the location is in Southeast Asia, and so on and so forth, right? And I will not run the complete sample. I will let you try yourself for the next sample, because I will cover the next. That is that's very interesting is how to build the VM into our resource group. Okay, so what we learned just now, first we deploy and change the files, and then we run the plans, we run the apply, and then I will let you try yourself with the code from my GitHub to use a variables and apply on your own. So let's go to the next demo. So the next demo, after we have the resource group, we'll put the VirtualNet on our resource group, right? And then we will put one NSG, and we will put a subnet, one subnet, 2.0/24, right? And then we will put the VM inside the subnets, and then we will also try to recreate multiple VMs. So how do we do that? So let me delete this resource. Because I don't want to have a conflict on the second samples. So let's open the second samples. The second samples basically will continue from the first sample. You follow if you follow by yourself, second samples is continuing for whatever you done on the first samples. Yeah. So I still have the same common files, but now I want to hide this one. Can I hide this? All right. Never mind. So this is my first sample, right? And then I will add a network. So the network will start from the VNet, virtual network. So we define a new resource, Azure Virtual Network. And then we define the address space 10/16. Okay. And then the same location using the Azure DevOps. So Azure Resource Group is the resource group, DevOps is this one. And then the locations, the location is this location. So Azure Resource Group, DevOps dot locations. So these are the reference that I use inside the my network dev files, right? Similarly for the Azure Resource Group, DevOps names. It's also coming the main files here, Azure Resource Group, DevOps name. This. So that's how you will be able to reference to the existing resources. And then I will create a app subnet. So the app subnet will have the IP of 0.2, 10.0.2.0/24. Okay. And then I will also add NSG, network security group. And in this NSG, I would like to allow the RDP to go in. So RDP traffic port 3389 protocol TCP inbound. Okay, so this one will be allowed to go in. And then similarly, I will add because it will, let's say, will serve the HTTP or HTTPS. So I allow the HTTP and HTTPS on port 80 and 443 inbound TCP, right? So this is my definition of the network security group. And then next is to associate the network security group to the subnet. So I will use the Azure RM Network Security Group Association resource. And then I refer to the Azure Subnet DevOps app.id. So Azure Subnet is here. Azure Subnet DevOps apps.id. And then for the network security groups, same. Azure Subnet Network Security Group DevOps.id as well. Okay, so here. Right. And then for VM, I will create a new VM layer. So I will create a VM. For the VM, I will assign a public IP so that we can connect from our machines. Okay, I have a Azure, and then we have the network interface for the VM. The same way we have and then we have a VM machine. So this is important, right? So VM machine will have the resource group name, network interface assigned, and the image that we are using. So Windows Server Data Center, and this. So let's start and run this. Any questions? Please just go through. So instead of running that, I will run this. So the same thing with Terraform. So let's start this one and see what is the initial VM. Later on, we log in, and on the third demo, we'll demonstrate how to create a full-blown VM with all installed. So imagine you have the SQL servers, you have the Visual Studio. So let's see later. Okay, so let's do apply here. So when we do apply, it will request us to type in yes, exactly yes. Why yes? Because if you don't apply, provide the answer, the exact answer, it will just ignore it because infrastructure is very, very sensitive. Okay, I pause here. If any questions, let me know. Okay, no questions. Let me continue. So while we are waiting for this one, let me show you what is the complete set for this, right? So that you can do on your own, because I don't have enough time here. Maybe for the next session. So what you can do later on. So just now we create only one single VM. How about if you want to create multiple VM, right? So the Terraform provides other opportunity to do the looping using the count. Okay, so the origin of I will add a count here, count that will detect the Terraform of how many total VMs that will be instantiated. So similarly, we use the count for everyone, every things. So similarly for the name, I use a format, the var VM base, the count index. So you give me the name of using the two-digit, two-digit VM number. So for example, app base name app dash 0201, something like that. Okay. So do we do it for the IP configurations? We do it for the virtual machines. We define with the count here, and then we give using the format name, so we can format the name of the VM based on the index number. Okay. So the rest will be the same. So it will take some time for this. For the demo number 3, it will be 12 minutes. So I will just proceed quickly to the demo number 3. Otherwise, we will not be able to complete this. I'll show you what do we do on the demo number 3, so that we can finish this on time. So while we are waiting, so we'll get the FQDN, etc. Any question? Let me stop here. If you have any questions, just prepare for the demo number 3. So it creates the public virtual network, public IP, network security groups, and so on and so forth. You can see the okay, clean up things. So we create the VM. So while we are waiting for that to run, and later we check what did we learn. So we are using the count to create a multiple instance of the resources, and then we use the interpolation syntax to create a dynamics name of the resources, and then yeah, so we can use the current Azure subscription and the current sessions, and we need to avoid the hard coding of the sensitive principle. Yeah. So for yourself, you can read more about the for in X syntax in this link, and then the expression syntax in the second link. Okay. So while we are waiting, let me show you what we are going to do on the demo number 3. So number 3, we yeah, number 3, we have successfully created subnet with VMs with any number of VMs by using count. So here we will create a new subnet for the database. Okay. Oh, all right. So let's see. Let's see. What should Okay. So my time is almost up. I have a call. Okay. Let me show you what is the number 3. Okay. In number 3, right? I'll show you additional how we create a VM that will install Visual Studio inside Visual Studio well after it's running. Okay. So here the same VM I will add the same dimension. I will add custom data. So custom data will contains my app init.ps, which is my installations instructions. I'll show you this one. Oh, okay. Yeah. So I will install a Google Chrome, JIT, Visual Studio Enterprise, and so on and so forth. So this is the PS file. And then back into VM, right? I will call that installation file using the Azure Virtual Machines extension. Okay, this one. So Azure Virtual Machine extension. So I'll just run this one with the extension. Oh, my machine is slowing down. I don't know why. Yeah. So this one is extension. Call that one. So you can go and check. Similarly, I also prepare for the database installations for the DBVM. All right. So I'll pause here if you have any questions because my time is already up. Yeah, so this one for the DB. So for the DB, I will install the SSMS, I will install the SQL Server. So this machine, this installation script will be called by the Azure extensions script, and then when you have the VM instantiated, and then you go in, you immediately will get that installed. Okay. So yeah, so I let you go to the resources that's available here. Okay. And if you have any questions, please let me know. Any questions? Okay, so let me check if there's any question. So we will go for the next session. There's no more questions, then we'll do for the next session. Sorry. Yes. All right. Okay, so there's no questions, then we will hand over this back for the next session. And